And welcome to Chemistry with Mr. Olson. Today we're doing gas law stoichiometry. And I have the diagram here showing regular stoichiometry, grams to moles to moles to grams. In other words, grams of X to moles of X to moles of Y to grams of Y. And the grams to moles or moles to grams of any substance, X or Y, that's the molar mass from the periodic table and the chemical formula. At the heart of stoichiometry is where we go from moles of one substance, moles of X, to moles of Y. And that's where we use the mole ratio from the balanced chemical equation. And in gas law stoichiometry, we can also go from moles to liters. If we're at STP, then we know it's 22.4 liters per mole. But if we're not at STP, we can use PV equals nRT, assuming we've got enough of the variables identified and we know the quantities. Okay, so let's do the problem. This is problem number 2 on our gas law worksheet 3, and we have to write the balanced chemical equation. So magnesium metal plus carbon dioxide gas react to produce solid carbon. So that's just carbon, its formula is C, plus magnesium oxide. Magnesium is +2, oxygen -2, so that's our white crumbly magnesium oxide powder. Balancing this, let's see, 2 oxygens, we're going to need a 2 there and a 2 in front of that. And now we've got our balanced chemical equation, which gives us all sorts of mole ratios. In this one, we're going to use 2 magnesiums for every 1 CO2 molecule that reacts. All right, what mass of magnesium will react with 250 mils of carbon dioxide gas at STP? So that STP tells us we can go between liters and moles very conveniently. Let's start by converting this 250 mils to liters by moving the decimal point 3 places. Each milliliter is 1,000th of a mil, so we have 0.250 liters of CO2, and that is our given. So let's write that ideally in a different color pen, but there we go, black. Let's start with black way over to the left. Here's our given, 250 liters of CO2, and we're going to use given times conversion factor, stoichiometry style. So our first, we have to get into moles. So we want to get out of liters of CO2 into moles of CO2. How many liters per mole? Well, this is at STP, so we know 22.4 liters per mole, and let's fill in those numbers, 22.4 liters per 1 mole. And now I'm going to do this one in red because it's a very different conversion factor. We're going to get out of moles of CO2 and get into the moles of the substance we want to talk about, which is magnesium. What mass of magnesium? So we want moles of magnesium. And let's see, I see here 2 moles of magnesium react with 1 mole of CO2. So 2 to 1 ratio. Okay, of course we're not quite done because we don't want moles of magnesium. We want grams of magnesium. So we'll get out of moles of magnesium into grams of magnesium. And looking at our periodic table, we see magnesium 24.3 grams per mole. So 24.3 grams per mole. And that is the units we want. So let's cancel units. Liters cancels liters, and moles of CO2 cancels moles of CO2, and moles of magnesium cancels moles of magnesium, and we get our answer, which to proper sig figs, which is actually 4. Actually, I left out one of the zeros there. This will turn out to be 0.5426 grams of magnesium, and that answers our gas law stoichiometry question. So, remember that we can go, all roads lead through moles, and we can go from grams to moles, or at STP from liters directly to moles. And have a nice day. Ta-ta.